Okay, I'm going to write the topic for today is to use linear models to make predictions. Use linear models to make predictions. And I'm going to place it on the top of the page so you can see it better. Okay. Now in the example one, we need to use the slope to make a prediction. So use the slope to make a prediction. Okay. Micaela is a speed skater and hopes to compete in future Olympic Games. She researched the winning times of the past 50 years. If the trend in faster speeds continues at the same rate, how can she use the information to predict what might be the time to beat in 2026? Okay. So the first thing that we need to do is to write the coordinates, the scale, and to draw the graph. Okay, to draw the scatter plot. Okay, so in the text for the coordinates, I'm going to write 10, 20, 30, 40, 50. We finish in 50. I think I can have more space. Okay, now I place it in here. Remember, this is the x-axis, okay? And this is y, and I'm going to write the coordinates 2.8, 2.4, 2.0, 1.6, 1.2, and 0.8. This is what we have for this. I think that we can have it in this. Okay. Now, where is going to start the line? Where is going to start the line to see the trend line? Is going to start in 2.4. So if you already know that it starts in 2.4, this is going to be our y-intercept. We are going to use it later when we find the equation for this graph. So if we have this line finished before we reach the x, but after the 50, it has to be after the 50, okay. We have something like this, and I'm going to change now to draw the points with you. Remember, I'm not going to place the points in the exact point. I'm going to draw the graph, something similar like we have in the books, so we can work with that.
Mr. The y-intercept is not in the 2.4.
Okay, now we already have this part. I'm going to draw with you the points. The first point is located in here, 2.4. Later we have another one in here. We have two. We have other one in here. We have other 2 points below. We have other one in here. And we have the other points. Remember, it's something only to show you what is happening in here. The important part is to find the equation to predict what is going to happen in 2026, okay? According to the speed, because she wants to participate in the other Olympics, okay? So what's the deal with this? She recorded for the past 50 years. She write, for example, okay, the facts for the last 50 years, they are in all this information we have on the trend line. So she wants to use this information to predict what's going to happen in the year 2026. So it's about using the information of the past to know or to guess what is going to happen in many years in the future, okay? And how can we know this? Because you can see that the points are adjusting to a line, okay? It's like the rate of change is constant, okay? Remember that when we have a line and we find the slope is constant, the slope, what is? The constant rate of change. So if in the past 50 years, the change is similar, okay, is approximate, then in the next years, you know that it could be approximated too. So that's the idea of this, using the information for the past events to associate with the events that doesn't happen, that are not in the moment, to predict what is going to happen in the next months or years, okay? So I'm going to write with you the equation. What is the form of the equation? Y equal mx plus b. Remember about this equation? This is the equation for the line. For one line that doesn't start in the origin. Remember, if we have the y-intercept, if we have one value for b, then the graph doesn't start in the origin. In this case, it starts in 2.4. So we already know the value for this, and we only need to find the value for the slope, so we can replace it on the equation. How can I obtain the slope using this graph? It's easy. Remember that we already did it on the other classes, but I'm going to show you using the graph, okay? We can find on the book in the step 1, look at this part in red, the red triangle they draw. Write an equation for the trend line. To write in the equation, we have the y-intercept, then we find the slope, and how are we going to find the slope? If I mark in here, for example, imagine that this is in the half of this. I'm going to move it so maybe, okay. If I have 10, in the middle it could be 5, right? Because it's on the middle of the distance. Again, you need to imagine that it's on the middle because I know that it's not, okay? And for the other part, I'm going to represent the change for x. What's happening in here, guys? You have a separation, 2.4, and in here below you have 2.0. So this distance is 0.4, right? Because if you subtract, you obtain 0.4, but it's in the half of this distance. So it's going to be 0.2. I'm going to explain you with more details in a moment. Only let me write this, 0.2. And for the change in x, I need to represent 2. And for the change of x, if you start in 5, imagine that this is the half, so 5, and it finishes in 20. It finishes in 20, so if you subtract 20 minus 5, what is the distance you have? You already know the formula of the distance, so it's 15. You move 5 plus 5 is 10, plus 5 is 15, plus 5 is 20. So the answer in here is 15. Using this, you can replace in the formula for the slope. Remember, the slope is the change of y divided by the change of x.
Mister, can you repeat how do you get that 15?
Okay, yes, I'm going to repeat. Only that first I need to get to other point, okay. Remember, the slope is this change for y and for x. Is the constant rate of change. Constant is that I have the same change in all the points, right? Then I can find the slope using 2 points of the graph. But in this case, they don't give me 2 points. They don't give me, for example, 1 point located in the coordinates. They don't give me anything. So I'm going to use the change in the graph, the change for x and the change for y. You can see it better in your graph because your graph has a grid. And you can see how many units you move in y. You move only 0.2 and vertical, okay? Vertical and it's decreasing. So if the graph decreases, the slope is going to be negative. Since the first moment you see it in this way, it's going to be negative, the slope, because you start in the greater number and you go down. Okay, and the change for x, again, you were asking me, you can see better in the part that you have with the grid, Anthony. If you take in 5 and you move to the right part until you touch the graph, you finish in 20. So if you start in 5 and you finish in 20, the distance is 15. So it's easier than you think. It's only to use the grid to represent what is the value you have for the variables, okay? That's the useful part of using the grid. That's the way I recommend you. That's why I recommend you to use the grid, because we can understand better where is each point located on the graph, okay? And what else we have in here? Okay, to understand better, remember, like I was telling you in the first examples, the change for y divided by the change of x. In this case, it's a shame that I cannot show you the correct graph, but okay, if we finish in here, I'm going to replace, and later I'm going to show you, maybe using the app or something. Okay. Then we have the slope, m is equal 0.2 divided by 15. M is going to be equal 0.0133. Okay, this is what we have for this one, and it's going to be negative because this 0.2 is negative. Remember, we decrease, we go down, so it's negative. We can write the equation now. Y equal mx plus b. And we have all the values. Y equal m is negative 0.0133 x plus 2.4, that is the y-intercept, okay? This is the equation we have, but they are asking you in the step 2, use the equation of the trend line to predict what might be the winning time in 2026. What is going to be the winning to predict, okay, for x? If I use the last point I obtained in here, you can see that is after 50. So they give you the exact value, that is 66. It's hard to know in here that it's 66, but they give you the value. So y is equal negative 0.0133 multiplied by x, that is 66 plus 2.4.
Mister,
Tell me.
but why you multiply by 66?
66 is the number that they are going to replace. Is the number of years after 1960. All the points you have represented in here, okay? So you use the point that you want to predict. In this case is the 66 for the year 2026, okay? They already give you the point, okay? So there's no way to know how they obtain it. They obtain it with the investigation Micaela did, okay? But in this case, we cannot know how she obtained that, okay? It's only to replace what the exercise gives you. So if 66, you multiply it by this, you obtain that y is equal negative 0.8778 plus 2.4. Then we have that y is equal negative 1.5222. Okay, I made 2 points in here. If the trend in faster times continues at the same rate, Micaela should target about 1.5222 minutes or 1 minute and 30 seconds. Okay, Now that I finish in here, I can show you maybe in the GeoGebra app, only to show you again how to find the slope when you have this line and you don't have the points, okay? Or you have many points like in here. For example, in this part, only to use this to find the slope, I'm going to take random values, okay? I don't have any special in mind. So if I place, for example, in here, and I place the other point in here, I'm going to use a line, this line, okay? I take the first point and I touch the second one. And how can I obtain the slope of this graph? I'm going to look for the difference for X and for Y, the change. So for example, you start in 3, but you see that the graph is decreasing. So in Y, you are moving vertical but decreasing. So 1 unit and 2 units. Why I only move 2 units? Because in this point you have this touching the graph, so you stop in there. And I show you using this app because we have the grid too. Okay, so you can see it better in this part. Maybe if I use a pencil, I can. I cannot draw a straight line, a completely straight line with this.
You choose that two first point because they are son los primeros dos puntos que están tocando de la línea, ¿verdad? Por eso los eligió.
I choose this because they are completely fitting the grid, okay? And it's better that way. For example, if I choose this, is in the middle of two values, in the middle of this and in the middle of this. So it's hard to know what is the exact point. So I prefer to use this and to use this that is touching in the line, okay, of the grid. Of the grid. It's clear that part? Okay. So for example, for Y, I decrease 2 units. I want to have the text in here. Okay. What is the formula? Y equal M equal Y over X, right? And I'm going to write this in here. Okay. And now if I add the change for Y is 2 units, but it's negative, so it's -2. And what is the change for X? If you start in here, you can see that you start in here, right? 1, 2, 3, 4, 5. So the change for X is 5, and I place that M is equal to over 5. But this is going to be negative. Negative. So this is the slope for this graph. I find the slope only watching at the graph if I have the grid, because the grid is going to show me the exact value for the number that I'm going to take. Okay, that's the idea of this. So I hope that you.
In the letter B, finish in 6, no in 5.
Okay, one moment.
1.
So I think that if you tell me. I don't know if you want to ask something. Sorry, I interrupt you.
I understand.
Okay, very good. So if you don't have any other questions, I think that we can finish in here. And tomorrow we finish with the examples 2 and 3.